Hello. Hello, everyone. Welcome to this new series about the Amiga, and let's make a game for the Amiga. This is episode 1 of the Let's Make an Amiga game. It is going to be a very simple game. I haven't coded it, okay? So I only have bits and pieces of it, but I have a version of it that I will show you for another machine. It's aimed for beginners, and also it's aimed... Hi Massimo. Hi Massimo, thanks for the follow. Hi Lolo, nice to see you here also. So, first of all, before I start talking about the game, I need to say the usual, no? Like, as you now know, let me go to the browser, given that the browser works. Yeah, it got the wrong, okay, it will work. I'm on the wrong tab. Okay, so let's go to the right tab now. So, like, hi Heleve, and hi Kenneth. Thanks for joining. So, the first thing I always start my streams. Hi Arturo. So, as I always, when I start my streams, I always, let's say, go through our stuff as Phaze101. Please, I do not ask for anything except like our videos on our YouTube, subscribe to our YouTube channel, like our Facebook page. If you like what you see, you can go on Patreon. There are the videos of the stream that I do related to the book there. Of course, as you can see, there is still number 40 on Patreon, but on YouTube there is only till 20. That is because I want to give something back to the community that supports me, okay? It's not nothing else. Eventually these videos will all be on YouTube. The same thing is on Coffee, okay? And if you would like to discuss anything related to this game or related to the book, please come and join our Telegram group or come to our Discord group. Most people are in the Discord group, I have to say. There are about 100 people there, so it's more people there. Back to what I was saying, please subscribe to our Facebook groups, like our page, join Facebook, join Discord, and happy go lucky, I will be able to help you. um, the all the links related to Phaze101, how you can reach us, are, well, actually right now the browser, the chat just displayed them, but they are in the upper right hand corner. You will see them there through the whole screen, through the whole stream. You're going to notice two things on this stream. You're going to see two Amigas. One is the Amiga that you see in the lower right hand corner. Hi, Amok. That is the Amiga that I am used to. And I will explain later why two Amigas in a way. I am old school. I like the Amiga. I like to do things on the Amiga. So when there are things to show, I will be using that Amiga. When I'm developing, I will be on something else, which I will talk about in a minute. So the game comes from a competition. The idea of the game comes from a competition. A few, I think, months ago now, retro programmers inside made a competition. They called it Crappy Competition or Crappy Challenge, something like that. And I happened to stream all the games that took part in that. Amok, thanks very much. Oh my god, Amok. And from that stream, because I was already thinking about what to do for the Amiga and coding a game passed in front of me, let's say that, which I liked, and I said this is perfect for to be converted to the Amiga. Now the game is very simple, and I'm going to show it, okay? It's very simple, but it has all the things that we need to code a game for the Amiga. The Amiga has got bobs, okay? But I am not going to go there because even in the book that I'm covering right now, I have not covered them fully yet. But tomorrow probably I will cover a big part of it, but I do not want to be covering bobs. I'm going to show you how to write a game without using the blitter. So basically, any game that is for the 8-bit machines that had hardware sprites like the Commodore 64 is acceptable on the Amiga within those levels, let's say terms, let's put it this way. Also, this proves that if you read till chapter 7 of the book, you are able to do a game that we normally saw on the 8-bit machines. After chapter 7 is the advanced part of the Amiga, let's call it like that, and you can do more advanced stuff that normally don't find in the 8-bit machines. So this is why I'd like to go this route. Of course, the game I will expand. I have my own ideas of how to expand it, but for now, let's leave it simple and let's leave it till chapter 7. So I'm going to show the game in a minute. I need to go to my screen too. Now, I need to switch off the other Amiga. And I need to bring the Commodore 64 device. Okay. So, we have Vice. Okay. So, the game is this. First of all, thanks Massimo Bonucci for letting me doing this conversion of your game. So, okay, the text is in Italian, but forget that. It's the game that we are interested in. So the game is a simple one. It doesn't even have a proper intro screen, which I would like to have. But besides that, we can start playing it. And the game is quite simple. You have Mr. Pooh, let's put it this way. He's on the screen and he needs to avoid objects while falling through the pipe. So let's try to play the game. I need to click on it. There you go. So it is a very simple game. You only have 3 positions: left, right, and middle. In the middle, you cannot stay for long, else you die. Okay, because if you notice, the speed increases. Okay, this will be our, let's say, Amiga game. Okay, and on the left side you have depth and and energy. Okay, anyway, because I'm talking and trying to play at the same time, I'm making too many mistakes. Anyway, this is the game. I'm just going, he's going to die now because I'm in the middle. So this is the game that we're going to do for the Amiga. Of course, instead of the boxes, we will have sprites with proper things. Of course, we will make a scenario, not just the 2 pipes, etc. But the concept of the game will be like that. Also, we will have a HUD, which we do not have. The game doesn't have, except next to the pipe, the health and depth of where we are in the game. So this is the game that we will be building. You need a super novice level. Yes. Okay. So, as you can see, it's quite a simple game, but it covers a lot of things that you will need to do on the Amiga, because the Amiga doesn't have a fixed screen or a text screen like the Commodore 64. Okay, you need to open a screen, you need to tell it how big it is, and all these things. So it all brings you to how to do the setup and to start. As I said, it's a very, very simple game, but perfect for teaching 68,000 in my opinion. So the other thing that I'd like to talk about is, let me put the window away for now of Vice. The other thing I'd like to talk about is this. So most of you know that there is this extension for the Amiga to code 68,000 in Visual Code. Now, I started using this. I mean, I used to use it, but then I stopped. But because I wanted to do this series, I started using this extension again, because I thought nobody will be able to code, but nobody will be able to code, but it is, let's be honest, let's be fair. I mean, coding on the Amiga, as I like to do directly, I think some people will find it hard and it's not really good for beginners. So I wanted a way of making things simple. So I started modifying this extension with my own ways of thinking. I recorded a video and I sent it to the developer with the options and the changes that I need for this extension. And to my surprise, Paul, who I thank from the bottom of my heart, okay, Paul, I forgot his surname right now, Paul Reingard, okay, really, really thanks. Within 1 week, okay, he turned it and came back with the changes that I have made or that I proposed. And yes, the extension was there, it was doing things, but it did not handle multi-files properly. It had issues in running the emulators and all that stuff. I mean, not exactly, but it wasn't easy for an novice. So I suggested my ideas, and after 1 week, I started testing my own ideas on. So I'm sorry, I'm saying a little story here, but it's incredible how things turned into something that was, how to say, I just thought it in my head, and all of a sudden I just had it in front of me. The extension doing what I was thinking. So I had to delay because this series I was supposed to start it in nearly a month ago. But because of what happened, I delayed this series so that I can. Yes, but it builds it for you without you doing anything. I will be showing things, Amok. So I was testing this, and because I was testing it, I didn't want to start the series with the extension not yet fully there. Okay. However, now I have it. It's not yet released because Paul is updating the documentation, etc. of it. But I do have it, and I'm going to use it. I will be sharing with the extension with you. The extension will literally do everything for you. You just need to start coding 68,000. The rest is there. You don't need to worry how the configuration is of the Amiga. Nothing. It even comes with different configs, which I will show. So because of that, I delayed a bit my series, this series, and I do apologize in a way, but I think it's for the good that I did that. And I didn't want to talk a lot about it also because I wasn't sure it will be it will be up to what I was hoping. But Paul was really, really amazing. I just cannot thank him enough for turning it the way it turned out to be. So having said that, so that's an overview, okay? I will be showing it to you in a minute. I just need to continue to explain some more things. In the book, okay, that I stream every Saturday and Sunday, Saturday in Italian, Sunday in English. On chapter 8, there is a startup file. We cover a startup file. Now, I know I said till chapter 7, but because my intention is to extend the game, I will use the startup file, but you do not need to worry about it. You can still, if you want, skip the part of the startup file and code it as you know till chapter 7. It doesn't matter, at least in the beginning, till we do certain things. The reason why I'm using the extension, it also helps me to concentrate on the game code and not about the Amiga hardware setup. So that is, let's say, the plus sign of it. So, having talked about the startup file, my next thing in the list is this series is aimed at beginners, as you can see. Okay, Hound Dog, thanks for being here. As I was saying, this series is aimed for beginners and really beginners. So if you know more than a beginner, all I ask is let the beginners learn. Okay, certain things will be done in an, you know, when you were at school, you were using building blocks one top of the other. So don't go till the end if I am still at the beginning of it. It interrupts in a way, and it can confuse beginners. So I really would like to stay within those steps without offending anyone, of course. It's just that it is really aimed at beginners, this series. Please, and seriously, please correct me if I do mistakes. And I'm not saying typo mistakes but code mistakes. I'm happy to give you points, Twitch points, if you correct me, so that you can gamble like what Hound Dog like to do, or Amok likes to do, in this series, because it does help me out. The other thing is, this is personal now. You have never seen me, but I do have a problem with my hands, actually my fingers, okay? Sometimes my fingers do not move the way like everybody moves his fingers on the keyboard. It's because I have a problem called hypermobility arthritis, okay? It's not a common arthritis. The fingers do not move like, I mean, I think they moved, but they would not move. So sometimes I'm on another letter than the letter I'm thinking of. And because of that, I make mistakes while I'm typing. So please apologize for this, but it's a problem that I have and I cannot do much about it. Okay, so now I have done a design document for the game. It's a simple game, but I still wanted to do a design document for it. And I'm going to show you this. So based on the game that we saw, this is roughly our screen. These are just placeholders, okay? So it's not really, if you notice, I used squares. So somewhere in the middle, we have a tube where our character falls, okay? On the left and right, we will have something like walls or something. And on the right side is our HUD, okay? That's the game. I have let's say described the positions. As you can see, he's on the left side, he's in the middle, and on the right side. Because as you noticed in the game, in the middle, the character gains speed and then he dies. Basically, you cannot stay in the middle forever. As I said, these are just placeholders. I even put how many pixels, etc. Our game area is. So the height of our game is 256, the width is 240, the middle part is 48 pixels, okay? Each sprite in the Amiga is 16 pixels wide, so 3 positions, that makes it 48. So, and as you can see, between the play area and the HUD, there are 96 pixels. Anyway, this is information that we will need to keep in mind during the game, okay? Or if somebody would like to help and do the graphics, because to be honest, Hound Dog has helped me in doing the graphics for the game, but they can be better. I mean, none of us are GFX artists. I mean, Hound Dog is very good in 3D, but not so much in pixel art. So he helped me to the best that he can, and yeah, if somebody wants to jump in and do the graphics or help in the graphics, not necessarily everything, it's fine. I do have one of the Phaze101 members helping, and I will come to that later, in the intro screen and maybe in some sprites. So this is the HUD. Here it was just how big it is, and 256 pixels high and 80 pixels wide. Okay, the enemies we haven't really decided, or the objects to avoid. We haven't. You can either do animals, you can either do other things, or you can do a mixture of both. You know, it's like Ninja Turtles. They had spiders, crocodiles, all this stuff, or we can mix what there can be, like needles, cotton, cigarette, contraceptive. I mean, that was the idea of one of the members of Phaze101. Toilet paper, whatever. You know, it's whatever we need, whatever we need, we think is funny, we can put there. The sprites are the normal Amiga sprites, 3 colors, okay, and one transparent, which I covered in chapter 7. This is, it's not finished, but one of the Phaze101 members is the designing the screen, the intro screen, and this is the character at the front of the for the intro screen. Okay, it is 320 by 256. It can be 32 or 16 colors, whatever. Here I have some tools that we can use, and one of them is promotion, which is this tool which I have a license for. Okay, it's very good for designing pixel art for the Amiga. There is a free version of it. You can see that it gives you all these things, but I have the full version of it, so I have all the rest. Also, there are my friend Ozzy did this tool for designing sprites for the Amiga, so it's quite handy, and it also gives me the assembly code for it. And then for image conversion, one of the Phaze101 members directed me to this website. I think yesterday it was, or today, I can't remember, luckily, and it does the conversion what we need. It also can handle sprite, but I haven't really tested it because this is really fresh in my hands. But we can also try to use this this tool. It also creates ASIN files. So from that point of view, we have quite some cool tools. So this was the tool that I showed last. Okay. Now, before I continue, I have done this. So this is a page with links related to Amiga assembly. Okay. There are also the tools that I was mentioning. They are here, and also linked to the Amiga extension, which is not there yet, but it will be there. So I put the link to it. It's the old version, what you can find. But here you find links to programming the Amiga and programming and using 68,000 code. This link I will share in a minute. Same with the other links, but the most important thing is that you get the link of this page, and if you go, you can even suggest links for me if you want to, and then I check them out, and then I can approve them or not. So I'm happy to do that if you suggest me any links. The link to this page will have everything of the other links that I spoke about. Okay, so the tool for the bitmap converter or sprite of Ozzy, they are there. There are some other tools that I had mentioned in the course, so they are all there. So I explained the design document. I explained where the idea comes from. Now I need to say, so if I go to Visual Code, okay, we'll be using Visual Code, okay, for the development of our game. And we will stay in Visual Code all the time. There is no swapping between some other tool or the Amiga or something else. We will stay here and we will run everything from here and we will debug everything from here too. So one place for everything, not like before, okay? Because the tool is able to do this now. When we create a project, okay, which I will show in a minute, for now, we will be using one file. But as I said, the extension is able to handle multiple files. So bear with me till we arrive to that point, but it is able to handle multiple files and handle them properly. I'm losing my voice. Anyway, let me continue read from my script because I wrote a small script to make sure that I do not skip anything. As I said, we will split it into multi-files later on in the game when you understand better assembly. I invite you all to do the GFX for the game or help me out in the GFX for the game. I'm really hoping that you guys help me out on it. One thing that I didn't say, yeah, the video, this stream, it will be edited and it will go on YouTube, but it will go on YouTube after a certain time. It will go on Patreon first. Oh, thanks. I love it. Perfect. So the videos of these streams will be available later. Of course, they will be available first to Patreons. Probably I will do the first one. I have to admit, probably I will do the first one. I want people to know how to use the extension, so probably I will share that one. So this one, the first one, it will be there. The code of this game will be there till we do a screen. Once we open a screen and we display an image in it, I will stop sharing the code for now. Don't get me wrong. Why I'm doing this? Because I want you to go and code, not just see me. Okay? I want you to code. I want you to, what you learn, go and do it. So at a later time, I will share the code, probably when the stream finishes. But I want you to, at least my wish is that you go and code. Of course, I will make available any resources that we will use. But the code as such, also maybe you can do a different game than what I do. And then there will be different versions of it. So I would like to hold the code from being shared initially. I will share the first bits of it, but then I will stop so that you can start and also you won't have problems with the extension, etc. So making sure that that is fine. The code will be available on Patreon for Patreons, but so the code will be on Patreon, but also on Patreon I will not share, I will just do more help there, but I will not share it fully neither, because I want people to really go and code. in my case, I'm going to use source control. So I'm going to use GitHub to store the source of the game. But because I can imagine that not everybody knows how to use source control, the code will be per video. So if this is video number, stream number 1, then there will be code for stream number 1. When we go to stream number 2, there will be code for stream number 2, including, of course, what we did in stream number 1, and it will continue like that. So you can follow exactly the code of what we did and how we did it. I will show how to create a project with the extension, and also how to use, I'm going to use GitHub projects so that I can keep track of what we are doing. Yeah, as I said, it's not for everyone maybe, but I'd like to do that. The other thing is the code will run on A500 expanded. At least I do not see making a game that needs 1 megabyte of RAM, but I will make sure that it runs on A500 and it will run on A1200. Of course, the game is OCS or ECS, but it will work on all these machines. In fact, the extension will take care of this, and I will show you about that. So let me first share the page with all the links. This is the page. You can go and hammer it. So the extension, I will share it at the end of the stream, not right now, because I want to show you. I do not want to be interrupted in the middle when I'm still showing you how to do it by somebody trying to using it with and being ahead of me and experimenting with it. So I will share it at a later time, the extension. The extension, as I said, is not available for download. It is available from my link. Eventually there will be an update. The wiki is not updated yet with what I'm going to show, so please bear with Paul. But really, thanks to him, he did an amazing job, and I thank him also for, you know, taking my advice and my suggestions for the extension. So let's me show you first what we need in Visual Code. So the extensions that you will need is this one, the 68K counter. This is not part of the extension that Paul is doing, but it helps you. It has some bugs, okay, but or defects, let's put it this way. Sometimes it misses to calculate the things right, but it's able to tell you when you write a 68,000 instruction, well, how much memory and what is the speed, how many cycles it uses in the editor. So as you can see, it is showing the cycles and how many bytes an instruction takes. Also, if you highlight part of the code, it will tell you how many cycles and how many bytes that part of the code is taking, and this is good for optimization basically. So this is why I like this extension. The other extensions that I'm using is for Visual Code. I'm using Visual Code icons so that my icons look nice. I am using the formatting toggle you don't really need to install this, but I sometimes find myself wanting to switch off the formatting. So I have this option. If you use Workspace, you cannot do that, but because Workspace always override anything else. But if you're not using a Workspace, then this extension is quite good, formatting toggle. So this is the other extension that I'm talking about. Of course, I have GitHub, okay, because I'm going to use GitHub. This one, you can install it if you want, but this one is installed by the extension, okay? The file downloader, and you will see why in a minute. This is our extension. Please ignore the others. They are things that I do on the Amiga, other stuff, but this is the extension that we will be doing, we will be using, okay? This extension, notice the version is 0.22, okay? You're not able to download it. And this is the extension that permits us to do what I've been saying. So, after I explained the extensions, I need to say one thing. If you are using the old version of this extension, you need to go and uninstall it. I'm going to uninstall what I have, okay, just to show you. So I'm going to uninstall it. I uninstalled it. And I need to install the extension. All I need to do is go up here where there are the three dots, okay, and install from a VSIX file, because that's what the extension is, since right now you cannot download it from the portal. I have it in my downloads directory. There you go. This is the old version of it. And I'm installing it again. Okay, that's how you install it. It installs this for you, okay? So if you haven't installed it, it will install it. It will not be installed. Yes, you need to install separately, okay? The 68K counter. But you can search for it up here. If you type 68K, it should come up. There you go. And it's one of the, it's the extension. So we have our Visual Code ready for a drive with the new extension. So to create a project, this is something that it did not have before, okay? You either press F1, okay, or the usual, I'm still the old way, Control Shift P, okay, and you get the same thing. In my case, it's selected already, but you can type create and it will come up. And you need to use Amiga assembly, create example workspace. Let me see if I can make the screen a bit bigger. I think that is too much, like that. So hopefully you see it like that better. So when you click on it and you tell it to create, okay, it's going to ask you where you want your project. So I'm going to create a directory. You need to create an empty directory, okay? So I cannot do it here. So new folder, and I'm going to call it Twitch stream game, okay? And then select it and select the folder. Now it's asking, okay, And this is another thing that it did not have. It's asking what file should the main file be called. You know, like in C you had main, okay, main.c. In ASM maybe you could use main.c or whatever. I am going to call it game, okay, and it's going to create a whole project with game.s, and there's a sample code there. It gives you a sample code. It creates an Amiga HD, okay, with the C directory. I will come to this later on because I did enhance this, but it's my way of doing it now, okay. The extension doesn't need to do it because everyone has got its preference. And the S directory, so when you run the emulator, it will know which file to execute. And if we click on startup.sequence, okay, you will see that it will try to run the game, okay, which we haven't yet assembled, but there's a it knows already, the Amiga, that needs to run a file game. In include, there are the usual include files, okay, which, because we are programming the hardware, we will not really use, but here I will put my startup file. I will come to that in a minute. The game.s has got an example of it, of 68,000 code, and as you can see, it is what there was before. So once we run it, you will see what it will do. Now, this is the beauty of it. I am in Visual Code. I will go to the run and debug section, and as you can see, the panels open. These were there, some of them, and some of them has been enhanced, but these were there, where it gives you variables, watch, call stack, breakpoints, disassembled memory, okay. So these were there, but I'm going to select for now WinUAE run, okay, and I'm going to run it. And as you see, I'm in Visual Code and it's running the Amiga WinUAE with the code, with the sample code that there is, okay, and it's going to show us this was the sample code that the extension previously had, and it's still there, but I didn't do anything. It's running from Visual Code, okay. If I tell it to stop, I'm still in Visual Code and everything is there. As I said, in the lower right hand corner, that's my Amiga the way I like it, but that's me. In the bottom down here, okay, you have the things related to Visual Code, but errors related to assembling will be in problems, okay. In terminal, there will be what it uses, because the extension was installed in this folder under the user and app data, you know, roaming, etc. So, and as you can see, it's running, although it's installed under user and it is in C, it knows that I'm using drive E and it's under OneDrive, but actually right now OneDrive is switched off so that I can stream better without it. But normally all my code goes into OneDrive also, so that I can have it on all machines. So there will be some text here related to what it outputs, but the main screen that you need to look at is here. It might also display messages down here, but I think Paul removed them all from here, and now they're all in this part of the screen. The previous extension, I believe, that used to do display messages down here. I'm not sure if they have all been removed or not. I haven't seen any messages there, to be honest, but I just don't know if everything has been updated or not. Now, I'm going to go to WinUAE debug. Now, what I didn't say is that WinUAE is configured to run an A500 with 1 megabyte of RAM. So it has the standard 512K chip RAM and another 512K expansion that we used to have on the Amiga. So if I run this one now, okay, it's going to go into debug mode. And as you can see, the registers are displayed. We don't have no watch list. It's telling us where the CPU is and it's showing us where it stopped. It stopped at this line 19, and the next, so it executed that line, this line, and the next line that it will execute, it will be line 20. That's what it means. It will show us, so if I make this, if we had breakpoints, it will show us breakpoints, and also it's showing us this assembly of the memory, okay, of where we are. Okay, you can see part of it down here. So back to the extension, back to the emulator. Because it stopped, there's nothing on the screen, right? But we can, from here, we can tell it, I don't know if you can read this, but it's saying step over, which is F10. This one says step into, which is F11. This one says step out, so we get out of a function, okay? This one is restart, this one is stop, of course, and here is continue, okay? So all the debugging features are there. There is one thing that I'm not showing, which in a way it's my fault, but it's not needed right now. We do not have hex display panel on the left hand side. I should, because the extension is not yet fully done, I should have done this manually, but I'm leaving that. We don't really need it yet, but the extension is able to do that, and eventually it will be there. And I've seen a screen today which I haven't used yet, where it displays a dump of, let's say we have this address here, it displays actually not that one, let's find copy list, okay, it displays dump of the address and also the contents. Look, there it is. This is today. This was done, I mean, Paul sent me this few hours before the stream. That is able to give us a dump of where that copy list is, okay? So it's quite handy. There is also one on the left side, which I do not have, but it's able to do this. So it's also interactive. I mean, it can do lots of things. If I tell it to continue to execute, I didn't set any breakpoints, okay? So if I tell it to continue, it will execute. Of course, it vanished from the screen because I clicked on the visual code, but let's bring it back. And there you go. It's what we had before, okay? So this is the extension and how you can use it. During this series, okay, I will be explaining how to use the various things that it has, but for now it's just sufficient to show it, and that you can code Amiga 68K in Visual Code without leaving Visual Code. and running everything from Visual Code. So that's quite a handy thing. There is the extension, there is more to it, okay? So for example, I showed you that it loads, okay, down here, I showed you that it loads its files into your C drive that it uses, and then there is the configurations of the Amigas there. If you want, you can create a GitHub directory with your configurations, and it gets those instead of what it builds for you. So this is actually how it started. I told Paul, look, I modified this to do this, this, and this, and and from that he went and built all this into it. So that was my initial thing, that I changed the configuration of the build of the extension. And from that it expanded. So yeah, and if you go onto the extension, and let me exit the Amiga here. I need to do FSUAE, but for now, WinUAE. If I go onto settings and select the extension, you can see, you can tell it where to get your, if you want your bin directory. Before it had a bin directory. Now this is configurable, and you can tell it from where to get stuff. Where your project comes from, etc., etc. It has all these things. These are all new things that Paul implemented. Maybe they were in his head. I don't want to say it's all my idea. It's far from it. I mean, credit to him for showing, doing the extension. But it's able to do all that. Now, I'm going to go back to the to this screen where we have run and debug. FSUAE has been configured a bit differently. WinUAE is configured to run in an Amiga 500 with 1 megabyte of RAM. FSUAE is configured to run an Amiga 1200, okay, with 2 megabyte of chip RAM. Right now, Paul thought that there will be too many configurations to include everything. I mean, he needs to concentrate on the code. So initially I wanted 2 and 2, you know, I wanted the FSUAE to have A500 and A1200, and FSUAE to have A500 and 1200. But then he told me, let's do 1 and 1 for now, which is right. I mean, it's lots of configuration to deal with. So right now, FSUAE can do 1200. So if we run it, okay, you will see that it starts here. It's saying Amiga 1200. Okay. Now also note that the bar moves faster in FSUAE. Some people do not like to hear this, but timing in FSUAE is not as good as WinUAE, especially for people that are just think about Linux and Windows is crap. I mean, Windows has also some good things, and WinUAE is one of them. So this is why it's faster, because the code, even though it's executed on an A1200 with a faster processor, because we are using the screen refresh, it should be in sync. Which it's not, but it's okay. And of course, there is the same thing for FSUAE debug, same as WinUAE. One other thing that I didn't say, I'm sorry, I'm talking a bit too much about the extension, but it's quite important for when we are developing, okay? Both FSUAE and WinUAE use AROS as kickstart. None of them, I mean, the extension doesn't provide the ROMs. You need to upload the ROMs and configure the extension to use the ROMs, which I will show probably when he releases the extension, I have to say, because there are some parameters that I'm not sure if he's going to change or not, or if they're going to remain the same. But for now, with what we are doing, it's fine. But we are using AROS here. So if we need to use Kickstart 3.1 or Kickstart 1.3, and note, I'm saying Kickstart, not Workbench. We are programming the hardware. The only thing that we will have is Kickstart. There is no Workbench in no way, because we are programming the hardware. Load Workbench only works when you load it. So the OS only is there when you load it. If you don't do load Workbench, the Amiga doesn't have an OS, but have Kickstart and just waits for you to insert a disk. So, of course, if you're running from a hard disk, you're doing load Workbench. So this is the extension and how we will be using it. So I have created, if I go here, I have created a project that will permit us to run our game. As I said before, if I created another file, let's say new file, and I'm call it main.s, before it used to fail. This doesn't happen anymore, even though we are not calling main.s. I hope it doesn't fail, and I hope that the latest build doesn't fail, because I haven't tested this part. So I'm going to run it, but it should be fine. And it is. Before it used to fail, and now, as you can see, it's running. Okay, we went to the debug mode, so I need to click back, but it ignored the file. What used to happen before, okay, and this was the issue that I also highlighted to Paul, was that in the build directory, you can see that there are two main object files. It used to go into the root directory, build everything, and then try to link between this and this one, but main.s, which is object main.o, there is no link between them. And so it used to fail. I'm going to delete these two. And this was due to, I can tell you what it was. It's here. He had star.star/star dot in includes. So anything in root and below root, it will try to assemble and link in using the vlink command. Anyway, so we need, let me see what else I have in my notes that I have not explained before we start coding. Okay, I think I said everything. So enough of talking and let's start. So there is one thing that I didn't cover, and that is my style. So everybody has got his own style of coding, right? And I'm going to show you my style, not because I think my style is the best, but it's the way I code. So that you know. First of all, you see this thing where there is couple list. I tend to divide code, not in this case, but when it is a routine, okay? Let me find a routine. So the routine starts here. Okay, so I am used to do this, and you're going to see me doing this quite a bit. So when a routine starts, there will be the routine name, whatever, name loop, and all my comments in it. And it will be dividing this section from the next routine. Okay, so here we have a different section, so I'll be replacing this with, okay, and this is GFX, whatever. Okay, so that's one thing that I do. The other thing that I do, you are seeing a label. Normally I put labels on the line on their own so that they can be long as much as I want and do not interfere with the code. Also, I use tabulation here. There's something wrong with the tabulation for some reason. Anyway, let's do it like that. The other thing is when it's a dot and a label, that means it's local label. Local labels, I always start them with a tab inside. That is me, okay? So most people start them on the first column. You do not need to do that as long as you put a colon, okay? Also, I always put colons into the in a label at the end. Some people don't, but I always put colons. So the other thing is when I have code to document in the same routine, okay, let's go down here. Maybe there is, okay, this is the same routine. So like this one, okay, I use, show you, because I have like a template. Come on, here it is. Instead of double, instead of the equal sign, sorry, I'm losing voice. I use this, okay, and whatever. So that means comments in the same routine or subroutine. If the sometimes I indent these, it depends on the code, and you will see me doing, you will see me saying doing this. But this is my way. Some people might agree, some people might not, whatever. Do the code as you like. For me, the most important part is that all the code, all the labels are on a line on their own. That's very important for me because like that I do not have problems of length. And that labels and that local labels start tabulated, so that I know that they are part of a routine, those labels. Having said that, I said we're going to program the hardware. So the include files that come with the Amiga to program the OS, we're going to tell them bye-bye. So the first thing I do is modify these and I delete them. I will not be using them. If you're going to code for the Amiga in the OS, then you will need them. But for the hardware, no. There is only one, which is the hardware.i, but in this case, we do not need it neither. What we will need is the startup file. Hence, let me find it. And the startup file comes from the book, okay? So I will so there it is. The startup file was copied into the directory where we have our game. Now, the startup file needs certain things which are little, but you need to know. It needs to call, it always calls a routine that starts at start. The name is start, okay? So our code should start with a label named start, okay? So the first thing we'll do is clear up here. And there's no more code in game.s. Now it's going to be our code. So we need, as I always said, I always start. We're going to configure the things needed for the startup file, which is little, but I'm going to do other stuff besides that. So the title, the game, I'm going to call it, okay, like what it is called on the Commodore 64, Mr. Pooh Journey, okay, just for the fun of it. Okay, so I just had this prepared, okay, so we do not need to waste time on it. We will need, and for those that were following me in the book, we will need a section, okay, where our program will be, okay, and that is, we can call it whatever we want, and we can call it game. Use capital. Doesn't matter, to be honest. What's important is what follows. It is code. Why? If you recall from the book, the Amiga, when it loads a file, it sees the hunks of the file, the sections of the file, okay? So it knows which part of memory the code needs to go, where the graphics needs to go, etc., whether it's chip mem, fast mem, etc. In this case, code means it goes into fast mem or slow mem, if you want to call it like that, if it's available, else it will go into chip mem if you have just 512K of RAM. I mean, all this was covered, but I'm just repeating it. The name is just a tag. You can do whatever you like. Okay. Then we need our startup file. So here I have some comments for the startup file, what it does. And then the startup file. Don't think that is going to be always cut and paste, okay? This is because it's in the book. It's useless doing it, okay? So, in fact, look, there is still the comment in Italian, which doesn't need to be there. As you can see, our include file, our startup file is in the directory include, so we just did include startup.s. Now, I just copied this for the sake of people, beginners that do not know this, okay? So I copied it and I prepared it. Normally you don't do this, okay? But I just prepared it because, as I said, this is for beginners. Here is the bits for the DMAs, okay? What they mean and how we need to set them. So basically, we need to create, I mean, this part I edit myself, but this part that I'm going to copy now is from the book. Hi Twitch Igor, thanks for joining. So, as you can see, and this is also a habit of mine, which I learned from the book. These are the bits that reflect what we have up here, okay? Thank you, Retro Gamer, for following. I have explained what all these mean, and what you need to know in this case is that I'm enabling the copper, the bitplane, the DMA, the sprite DMA, the sound DMA, and they are here, okay? The other ones, this is a register that you need to tell it whether you're setting or clearing. So you need to set one up here, and then you need to set bit 9 to 1 so that these can be activated. It's a way the Amiga was done, okay? But they reflect, I mean, I don't think I can make it more simple than this. By putting this up here, which DMAs we are enabling. We know for our game we will need the copper, the bitplane DMA, the sprite DMA, and the sound DMA. The copper is to have colors. The bitplane is to have screens, sprites is to have sprites, and sound is to have sound. Okay, so quite easy. Now, this is what the startup file needs, okay? That label start. So it knows where our game code starts. And at the end of it, okay, I use 2 tabs. Each tab is 4. You can see it down here. I have tabulation of 4. And the reason why it's not 8, because normally it's 8, is because, as I said, I use dot for inner loops. I tabulate them also one to the right. So instead of using tabs of 8, I'm using tabs of 4 so that I can do that. And here we have to have RTS. That is what is expected from us when we use this startup.s. Okay? And we need to save it just for the, as you can see, it tells you down here, the startup file already took 830 bytes. The startup file makes sure that we take control of the hardware in a clean way. Okay? Till chapter 7, I'm showing how to take control of the hardware, but it's not elegant. With the startup file, it is elegant. Before we continue, I told you I'm going to use GitHub, no? So I'm going to upload this code to GitHub because I want to do something else, but first I need to upload the code and show you something also. So if you go on source control, okay, you need to have a digit extension installed. Okay, I'm going to initialize a repository on my GitHub. And I'm going to tell it, I'm going to commit. I could have used the other option, but I want to show you what happens. Where's commit? Let's say that. And then I'm going to tell it to publish the changes, which is everything, you know, that we have done so far. So it asks me the name of the repository and where it's going to be, in the private repository or in the public repository. I'm going to make it private for now. As I said, the code that I will share will not be on GitHub, but it will be elsewhere. So let's do that. And here are the messages from from Visual Code that everything was done. I'm going to open my GitHub. Okay, and you can see that our code is there. Okay, that we just did. Now, why I came here? I came here for a reason. So before you start coding a game, you think a bit, no? I did this design document, no? You think a bit of what needs to be done. So I have the habit of, and I created one, of creating a project, which I did. As you can see, it's the name there. And I created a project on GitHub for this project. It's not linked yet, I will link it. But what I'm going to show you, and this is quite, for me, I find it quite important, okay? I know where I am. So I'm going to add some columns, okay? Which I will call to do. I'm going to add another column, which I'm going to say in progress. Another one done, or better completed, I think. another one, I'm going to call it issues or bugs, whatever. Let's keep it issues so that it doesn't sound so bad. Okay, now in the to-do list, okay, I start adding what I'm going to do. Okay, so for example, I will need to create a screen. No, the game will need that. It will need to load, display an image. We will need I'm just going to think randomly in a way, but display player. I will tweak this, okay? I'm just showing you for the sake of display enemies. I would have prepared this, but I wanted to show you for those that have never used this. One thing that we will need, and we will need it from the beginning, is a random number generator. We will need a way to print to the HUD. We will need to control the player now, so joystick control. Update the enemies or the baddies, whatever you want to call them. Enemies. And update the score. I'm not going to do them all, okay? I'm just giving ideas. Update high score. Although the game doesn't really have score and high score, but we have display an intro screen, no? What did I do? Display game over screen. Okay. I am going to now select one of them, which is where is it? Display, create a screen. Okay, and I'm going to move it here. So this is our first task. Okay, we need to create a screen on the Amiga. This is why I came here, to give you an idea of how we will work. And once I've done it, I say completed. Okay, it's just to keep track of where I am. While when I go offline, I will be updating this. Okay, I will be expanding it, and once we complete a task, I will move it into completed. Sometimes you'll do a task and you know that there are still issues, so you move it into issues. Okay, one thing that I haven't done is, although I created this project, I haven't linked it to the project, so I need to link it. to the repository, sorry. So I need to link it to a repository. Twitch. There you go. And we are linking it to the project. Okay. So let's try to do this task of opening a screen. Now, I'm not sure we have enough time to do it, to be honest, but let's try. I'm noticing that I haven't even taken a break. So, the first routine that we need an image, which I have. So we need to load the image or include the image so that we can display it. I think that's the best way of describing it. So I think, okay, let's do this. I have an image, I'm going to copy it and put it at the end. So I need to copy this screen, which is raw, to a directory called GFX. Okay. This image comes from you know, what me and Hounddog were doing, to be honest. So, and where we were doing some tests. So I need to create a directory. Let's call it GFX. I can already see that I made a mistake. Well, not mistake, but I forgot. I need a section. Remember, graphics in the Amiga go in a different section and they need to go into chipmem. So let me copy first the image. And actually I can copy also the font that we will need. So under GFX, we have our image and our nice font. In this case, I have this label called game screen bitplanes, okay? And game screen bitplanes underscore n. Sometimes you need to measure, I mean, to get the size. So it's easy to do this label minus this label instead of doing a calculation. So that's why I have two labels at the end. This is something that many coders use. Since we are in the GFX section, we need this section, okay? It's graphics, GFX, and it's called data underscore C. Why data underscore C? Because we need it in chipmem. Of course, we need a copy list, but for now, let's not talk about the copy list. We need to somehow display it, okay? For that to happen, we need the copy list, but we also need a routine that sets up the bitplanes. Now, I am going to, and this is also code that I prepared because this is the initial things and we did them so many times in the book that I thought we should not be wasting time on it. Okay, so I'm going to bring a copy list which I created, and I will explain it instead of this copy list is all in the book. Okay, so I find it we do not need to spend so much time in such a on such a thing. But I will explain it so that for beginners that do not know what we are doing. So I will copy this further down. Also to divide it. And here I would say to be honest, this we do not need. We do not need. I thought I did section twice. So as per book, okay, I am initializing the sprite pointers to 0, okay, as you can see here. And these are literally copy and paste from the book. Same for this part, okay, for the screen definition, okay, where we are setting the display window start and stop, data fetch start and stop, okay, the Bitplane con1 and con2, okay, and the modulo for the bitplanes odd and even, okay. I've added this because this register, okay, register 100, okay, we need to tell it how many bit planes we have. So we need 4, okay, 16 colors, low res. And as you can see, we are setting that. Let's see, let me close the bottom part. Okay, so we have bit 9 set. So this needs to always be a 1, okay, so that doesn't change. Then we are saying we have 4 bit planes and low res. So high res is bit 15, so we need to make sure it is at 0, okay, to be low res. And 4 bit planes is we are using these bits here, so 4 is bit number 14. Okay, I was going to say bit number 3, but it's 14 from these 3 bits, so it's bit number 2. Then we have the collision detection register, okay, which I'm going to skip for now. It's not important. We are not doing collision, but I prepared it, okay? It's there. This is what we need to set up. This is where we need to set up the pointers of these in the copy list for the 4 bit planes that we have. So this is the register, okay, the hardware register, and this is where the pointer goes. Remember, each hardware register, remember they are long words, so this is the high word, and this is the low word for the 32-bit number that we will paste for Bitplane 1, and then we do it for the other bitplanes. These are the colors. These colors I set them up, but as you can see, they are 0. I think I did some experiments, so that's why there are these colors, but we will override them once we load the image, because we will write a loop that reads the color from the image and sets these up. For the sprites, for now, okay, I am not reading anything from the sprite table, from the sprite data, but I set the sprites to have these colors, and they are on the same range. So, for example, this is all red in the red region. This is in the green region. This is in the blue or cyan, and this is in the brown, which is this is where the player will be. Okay. Here, this is a sprite structure, or how the Amiga wants sprites. I just made it. I've just put labels next to each one to make things easier, also as per book. Okay, so this is sprite 0, and this is sprite 0 v-start, h-start, v-stop, and the special bits for the sprites. This is the data, okay, for the sprite, which, to be fair, this will be overwritten. So here there's test data, but the program will overwrite it. Okay, and of course, a sprite always ends with 2 words which are 0. Here, I told you something about the images, but I'm doing it for a sprite to know the size of a sprite, okay, in terms how much data it needs. I'm just doing where sprite data is and where sprite end is, so sprite end minus sprite data, and I know how much memory that value is, so I get the sprite structure size basically. And here there are the rest of the sprites. We will have 6 enemies on the screen, okay, let's put it this way, or 6 different sprites on the screen in one go. That's the maximum that we can have, but the number of sprites, different sprites that we can have, images, we are not limited, to be honest, except by memory, so we can design as much as we want. I made space for 32. Right now I think I have 8, but whatever you help me with, I'm happy to add. So if you want your sprites in the game, we can add them. It doesn't matter, and even if they do not make sense to the game, it's just for fun. No, it's just adding sprite data. And here there is the player. So as you can see, I divided them. The sprite structures, I divided them with this is the player, and here each one of them is the sprite. As you can see, for the enemy, I did not populate them. I have just defined constant block of how big they need to be, because each sprite, I decided it will be 16, of course, pixels wide, because that's the width of a sprite on the Amiga, and 16 pixels high, so 16 times 2, because each sprite uses 2 words. So that's why it's defined block of 16 times 2. And here is our screen. Okay, so initially, okay, we will sorry, not we will, initially you will think, oh, he wrote the game. Actually, I did not. I do not have a game, but I did prepare lots of things that we will need for the game. This is when I was saying I'm preparing. So all this code is in the game, is in the book except this last bit. This the book has this, okay, and I created this, but the rest is in the book. So if you go on chapter 7, you will see all this. You can copy and paste it. You probably will find out. What you will not see is this, okay, the comments, so that a beginner can know why I'm setting, if you haven't read the book, why I'm setting those bits in for those registers, because they have meanings. That is all. So we will need a routine, so that will do the bit planes, yeah. So I'm thinking what I will call it. Okay, let's call it init bitplanes. We will need a routine that will set the color for the bitplanes, I mean for our screen basically. So my capital here, so leave it capital. Init colors. What else do we need? I think that's it for the screen to display an image. We do not need anything else. So now, this is how I do it. As I said, and I have init bitplanes. Oops. And here I will have init bitplanes. Guys, the wasm is case sensitive by default, and to be fair, I like it like that, so I'm leaving it with case sensitivity. So if you type something in uppercase and lowercase, you need to leave it, you need to always specify it like that, else you'll get errors, okay? And we need an RTS here. So that's the first one, first routine. It's empty right now, but you are getting the gist of how I do things. And here is init color. And init colors. Another thing, the extension has got, you know, while you're typing, it tries to match stuff, etc. Sometimes I don't like it, but most of the time it's helpful, okay? So we also need some type of loop when we display the screen. So dash loop, that's an inner label, okay? And then branch.s. Now branch.s loop, and here I made a mistake, it to be with coding. We will never exit once we display our screen, but this is just for, you know, demonstration purposes. I realized that maybe okay, some of you, okay, will be wondering, okay, what all these number of the copper are and what they are for, okay? For now, don't worry that much, okay? Bit by bit, we will be covering to them. I mean, I said that this is a sprite structure, but we are not going to do any sprites right now, so there's no need to explain what these are, okay? I just prepared the copy list so that we have it. It doesn't mean that I will not be going in and explain these, okay? Same thing for the rest of the copy list. Of course, we are going to deal with the screen, so I'm going to cover what we have here for the screen, okay, in a minute. But you do not need to understand the whole copy list. This is just preparation work. Homamis, thank you for the music. Yeah, and it's a Phaze101 music. It's not copied or something. It's ours. Giuseppe, is there something that you need to tell me? I see that you put an alert. Anyway. Okay. If you need anything, just give me a shout out or put a hey listen again. Ah, okay. No, because he redeemed sound, so and he did alert. So yeah. Okay, cool. So the only thing that I will not go into the detail and explain is the startup file. You do not need to know what the startup file is doing, okay? Because it is standard in the Amiga that you need to take control of the system. So you just need, imagine it like a black box and somebody told you, okay, use the startup file this way, and that's it. So all you need to know is there's the include for the startup file, and that you need to have a start, and it needs to end with an RTS. So basically, it calls our game, okay? What we will be doing is routines under the main routine. For the copy list, okay, as I said, we will come to it one by one. Each part, each section here we will be tackling and we will be coding against it. It's just that I prepared it, so we do not waste time in it. Imagine me writing all this, it's annoying for you. So I just prepared it and it's there. That's what I meant when I was saying in my streams, I'm preparing things for the game stream. So we need to code the init bitplanes routine. Now, we need two things. We need the source address where our bitplane is, which is here. So we need this address, okay? And we need the destination address where we will need the pointer of this one, okay? So this is an address. Now this is loaded in memory. Once we assemble it, it will be in memory in chipmem, because we are telling it to assemble this in chipmem up here, okay, in the before the copper starts, okay? So that address needs to go into the registers or register where we specify where we have our image. So that is an image that is for bitplanes. as you can see, is 320 by 256 and 16 colors, which is for Bitplane. The 05 is the version. Me making so many errors in the beginning of when I was creating the image. So that's why it's 05. So where does the address of this image go? That goes into this part of the cover, okay, where we have game Bitplane pointers. So the Amiga, okay, has got registers in the custom chip registers where you specify the address for each Bitplane. Now, our image is saved consecutively. So every 320 pixels by 256, okay, we start a new image, a new Bitplane. Remember, the Amiga is composed of Bitplanes. It can have up to 6 Bitplanes. We are using 4 to have 16 colors. Each Bitplane, when you put them one on top of the other, gives us color. Okay, I think maybe I will find it. Let me see. If I go, I should have a slide that I did in the book. Here it is. Here we have 3 Bitplanes, okay? When it loads. So we have 3 Bitplanes, okay? This gives us 8 colors with 3 Bitplanes. Each color is composed by this color, and this color. So these 3 together gives us color number 7, okay? And it continues like that, okay? So this, and this, okay, together gives us that is color number 100. That is it starts from Bitplane 1 because this is 1, so this is color 1, okay? It's this one, okay? Because Bitplane 1 is this, Bitplane 2 is this, whether it has zeros and ones, because each Bitplane can only have a 0 and a 1. Bitplane 3 is this. This is completely different from PC. PC uses chunky, what is called chunky bitmaps or chunky maps or chunky screens. Amiga uses bitmaps, okay? Bitplanes. And this is how we specify a color, okay? Now, the color, okay, let's say we are here. This is color number 7, okay, because we have 111. We go and look what is the value of color number 7, okay, and whatever the value, there is red, green, and blue, the pixel will get that color. That is how bitplanes and how screens are formed on the Amiga. In this case, let's take an example that we have. I said this one is color number 1, so you can see this is color number 1. It's 100, okay? Color number 1 is white. It's FFF. So it is a white color, okay? So basically it goes and look for index number 1, and it knows that it is white. That's how we get an image or pixel on the screen with a color the way we want it. So let's go back. Here we have 4 bitplanes instead of 3, okay? Each bitplane has got an address which is composed of this E0 and E2, okay? This we need to make it point to the high word of the address of the bitplane, and this one to the lower of the bit plane. So as you can see, maybe here it's more evident, okay, if you see them on the same line. This is the register value, so E4, and this is where we store our register. Now, E4 doesn't mean E4. The copper, okay, puts this value on it, in front of it, DFF, okay, and then it writes E4. We do not need to specify this, okay. The Amiga is intelligent to know that we are talking about bitplane number 2, and that is the register E4, where we specify the high byte of the bitplane pointer for bitplane number 2. Okay, so that's why E4. All the values in the copper list has got the value DFF. So even the colors, these are the colors, okay? If we take color 0, okay, which is the background or transparent, depends how you see it, there is DFF in front of it, but you don't need to specify it. Okay, so now we need to get the bit planes, okay, and set these values. How do I, the bit plane, okay, if I go, the image that we have has got 4 bit planes in it, one after the other. Each screen we said is 320 pixels by 256. That means it is 320 pixels division by 8 to make it bytes, okay, so it's 40 times 256, okay, so each bit plane is 40 times 256 in size, times 4 is how big our image is. We also storing color at the end of the image, so after the 4 bit planes finish, we are also having color at the end of it. So we need a routine that puts the pointers of our bit plane into the copper list address registers. So the first thing we do is move.long, and what was the name of that? Game screen bitplanes, yeah, there you go, into 80. Now some people will tell me, why didn't you use instead of move.long, why didn't you use LEA game screen bitplanes bracket PC close bracket comma 80? Because LEA you cannot use it across sections. We have 2 sections. This is the code section, and where our bitplane data is in the graphics section. So I cannot use LEA here. Remember, the move command is one of the most important commands in the 68000. It allows you to move data from memory to a register and vice versa, whether it's a data register or an address register. The 68000 has got 2 types of registers, D0 to D7, those are data registers, and it has got address registers 80 to A7, okay? And maybe write them here, data registers, there is D0 to D7, and Yes. A0 to A7. A7 is the stack, so you should not be using it. But some people mess with it. There are occasions when you can mess with it, to be honest. Because the 68,000 in a way gives you a way of having the stack where you want, in a way. This was one, I mean, the number of registers that the 68,000 had, and the stack, the way you manipulated the stack and stuff like that. At that time, it's why, in my opinion, was better. The 68,000 was better than any Intel machine that has got an 8086. Hound dog, you're gambling. You just came and you're gambling. Okay, so now to be honest, this one needs to be D0, not 80, for a reason. Game screen bit planes is because we're going to do calculation, that's why it's 0. Game screen bit planes, okay? We need the pointers, and the pointers, what did I name them? Game bitplane pointers. One is screen and the other one is bitplanes. Okay. I don't think I used the right names, but can I use LEA here? I can, because I'm not going to use PC, I think. Bitplane pointers, yeah. And this time, an address register. Now, we have 4 bitplanes, so we're going to create a loop. So, move quick. And we have 4 bitplanes. So 4 minus 1, because we're going to use decrement and branch, so it does 0 into the 1. So that's why I don't like it when it does this. I think we need a label here. Yes, because we are going to loop and then update, do the next bitplane. So let's call it next bitplane. Makes sense? Move.word, because the register, so we get an address, but we need to divide it in two, no? Because we have the high word and low word. Hi, I'm Eating TV. Nice to see you here. So we need, I need to think a bit. It's 0, yeah, because that's the source, into, I think it's 4, I will check it, into A1. So let me split this screen, if I'm able to display 2 screens, one next to each other. No, didn't let me. No, I split it like that. I want it. View to the right. Okay. Are you able to see it? Yeah. So on this side, I'm going to have my copy list because I'm getting confused. Those are the address registers for the Bitplane. So what we are telling it here, we have got an address and we are moving the low word into 4 bytes from A1. So this is A1 points here where the defined constant word is, and we are moving 4 bytes. So we are going to update this one. Okay, so I was thinking right. Then we need to do a swap. So what does swap does? Swap with 0. What it does is what was high word becomes low word, and what was low word becomes high word. Why we are doing this? Because now we need to store the high word into here, no? So move.word with 0, comma 0, of course A1, because the label is here, not here. Okay, so we are going to update this memory location. I could have specified, I could have removed it 0, but I prefer it to have there, and it's also easier for you to understand it. Then we need to set it back to what it was. So swap again. What I'm doing here, okay, this routine is a very, very standard routine of how to set the bit planes. I don't know how many times I typed it. So for me, it's coming natural in my head. It's just more remembering these, how they are in the copy list. Sorry, these. Okay. So now, remember what I said about a bit plane. The bit planes are one after the other. So we did the address of one bit plane. Now we need to add the number of bytes to the register, the 0, okay, which has got the start address where our image is. So we get the address of the second bit plane, okay, because so far we did the first bit plane. Like this, we just did the first bit plane. So what we do is add.long, okay, and our screen is 40 bytes wide, which is 320 pixels, times 256, okay, because that's the height. And we add that to our register, the 0. We also need to move the pointer in A1 because A1 is pointing to this address here. We need to, sorry, here, my God. We need to move it to here, okay? And the distance between this here, okay, where the dollar is, to this dollar here, if we had to count them, there are 8 bytes, okay? Each 2 is a byte, so there are 2, 4, 6, 8. So we start at 8, so we need to add 8. So add quick.word, okay? Immediate 8. So these are immediate numbers, okay? They are we are giving the processor the numbers ourselves. To A1. And now we have added both pointers. Now we need to decrement the value that we had in D1. So decrement and branch. Okay. D1. And we need to jump to the next bit plane, no? So we have our first routine, which will go through our image that we have in memory and set the pointers in the couple list for the bit planes. Okay, so the bit plane pointers will be set. Hopefully I do not have any bugs in it. I think I did it right, but because I did more than once this routine. It's such a common routine, but it's easy to make a mistake. So that's the first bit. Now we need to initialize the colors. So these are the colors. Now the colors are at the end of the bit planes. Okay, so we need again, I can copy it now. No, I can copy this, put it there. We need that for sure. Then we need to add, okay, this also is for sure, add.long and we need to add the size of all bit planes. So that is 40, because it's 40 bytes wide, the screen, times 256 times 4, because we have 4 bit planes. And we add that to the 0. Now, we got the address where our colors are. Okay? Thanks, G Brown, for the follow. So, we need, the first thing is we need the address that we have here, because we need to set the color here, no? So, we can copy this. I'm lazy, you know, in a way. And this time instead, oops, this should be game screen colors. Okay, and not the 0. We need, oh, thanks, PO1 for the follow. Much appreciated. And this should be, actually, if this is an address, this should be an address register, because we are moving into that. So here we can do LEA. Thanks, Amit TV. Thanks for the follow also. Much appreciated. So here we can do LEA. So now we have the address, and we don't need the hash, of course. So now we have the address of where these 4 zeros are. Okay. Now, if you notice, we said we have 16 colors now, so we need to go and create a loop for these 16 colors. So same as before. Okay, I'm going to copy that and move it down here. And this one should be 16. Remember, we need to do -1 because we loop till 0. So from 15 to 0, we are looping actually 16 times. Okay. Now we need, like before, instead of next bitplane, we need a label called next color. And basically, we're going to copy the values that we have in at this location, which is pointed to by the 0. They are word, and we're copying them into here. Okay, as I said, these are test values, so you can ignore them. The extension is telling me it's a yellow, but it's going to be overwritten. Okay, and we are going to populate all these. Okay, each time I'm going to add so from this one to this one, okay, that we need to add 4. Okay, there is 4 bytes, and we do it 16 times. So I hope it's clear, you know, the way I'm describing it. So move.word, remember it's a word what we are moving, not a long word or a byte, because it's got an RGB value. So it's a word. We get it from 80. So the contents of 80, that's why in brackets. We increment it. So after we get the contents, we can increment it. And then we store it into A1. A1 we do not increment because this one increments by 2 because it's a dot word, but this one needs to increment by 4. So that's why we do not increment it. So now, what is next? It's obvious. We need to increment A1. So add dot quick, add quick. Okay, we can specify dot long, but it doesn't matter. 4 to A1. Okay, so we incremented A1, and same like before. Okay, same as I have here, which I can copy it. Okay, we decrement D1 and we loop, but it is called next color. And like that, we should have done all the colors in on the screen. Okay, I'm just thinking if I'm missing something. I think I'm doing them all correct. Yeah, it should be correct. We will know soon. So we have our first part of the code that should display an image to the screen. Whether I'm right or not, we will see in a minute. Because this code is not tested, so we need to test it. Okay, so let's save and let's try to assemble it. course, first thing, put a colon. Save. Looks to be happy. Okay, and let's run it. So let's go into our extension. I'm not going to do debug, okay? And let's run it and see what happens. If there are errors, we will know. The Amiga starting. Please don't fail. And we see nothing, I think. Hmm. Didn't report any errors. So in our code, and we do not see a screen. Okay, so we must have something wrong in the screen. And it's either in the copy list, which I created, of course, this was not tested, or in the way we are displaying it. So what I'm doing wrong? Of course. Hold on. That was, I skipped a step. This startup file needs something else. Of course. Luckily, I looked at my notes. So we need this bit of code. Which the startup file doesn't do for us, to be honest. So here we are initializing, but we need to make it compatible with AGA and all this stuff. So we initialize the bit planes, we initialize the colors, but then we need to enable, okay? So this DMA set, we never set it. We just set the bits here in a variable, but we never initialized it. So we need to set DMA con with the values that we populated up here. Then we need to initialize the copper. We never initialize the copper. How do we initialize the copper? The copper initialized by specifying the address of the copper list. So this is my copper list. I always start my copper list with the label copper list. So it's standard thing what I do. And we move this address into 80. A5 points to DFF 0000. That is set up from the startup file, okay? Once we set the pointer for the copy list, I will show you these registers in a minute. Right now I'm explaining the code, but I will show you the registers. We need to initialize the copper, and you can put any value into register 88. Remember, there's because A5 points to DFF000, it is doing DFF08, sorry, 0088, okay? Um, once I just need to correct myself on something that I have said before. The register is that. Okay, the default value that the copper always accepts is that. Okay, so if we have a register of say 180, it is DFF180, because I think I said 180. That is wrong. It's 180. Okay, I'm just correcting myself. If I made this mistake earlier, I do apologize, but it should be DFF180. So the high bit here, the high nibble here is not used. Okay, it's just for to make it look nice. I use it, but it's DFF188, for example. Here it's DFF0E4. Okay, so please bear with me on that. This is how you initialize the copper. I will show you these registers in a minute, as I said, and here accept this as standard. This is how to disable AGA for being compatible. If you have an Amiga 1200, you need to run this. Once you run this, the copper should be okay. So let's run it again, because I don't think I had issues with the code. It's just I forgot this part. So it was not displaying anything because the copper, there you go. The colors don't seem right from our image, but we are displaying the image. So there must be some color that is not set up correctly there. It's fine. I can live with that for now. But we have the image displayed on the screen. I don't even know if the image that I'm using has got a defect in the colors. So I need to check that before I say the routine has got something wrong. But we have an image on the screen with the colors that which are not 100% okay. I prefer explaining the registers in this case. So first of all, 80 and 80 and 88. Okay, so let's get the browser. And let's go here. You have a link to this in the link that I provided. So it was 80, okay, 80, which is coprocessor first location. Okay, so we are moving at dot long, so we are affecting this one and this one. So this is the high high word of the copper address, and this is the low word, and we are initializing this with an address where our copper list is. So you can do a move long because they are consecutive. You are writing in both registers in one go. The 88 is how you tell it to start. Okay, you can see that it starts reading your copper list. So basically it went, I'm just going to move it a bit away. It went, we pointed it to our copy list, it went and start reading the copy list from up here and doing it one thing at a time. Okay, of course not where the comments are, where our copy list is. Okay, copy list ends with this instruction. So this is not part of the copy list, this is the sprite data structure. Okay, so a copy list is how we display things on the screen. And it always ends with this instruction, the FFFFFFE, end of copy list, as you can see from my comment. Okay, just accept that for now. So I am going, how long have I been? It's quite more than I planned in doing. I know I have a bug in the color, but I need to check if it's the image or the routine. I don't think it's the routine. I think it's the image, to be fair. Um, so I'm just going to check it again, just to make sure that the colors are fine. But just looking at it, looks fine. And should be fine. Yeah. Move word add dot long to a1. Decrement 1 to d1. Yeah, it should be fine. And this one we are adding the right value, 40 times 256 times 4. Yeah. This one is definitely okay because yeah. Mm. So is it taking these values at least? Let's see. Because now I'm intrigued in a way. It looks like it did these colors, but never did. So because these colors are set, so let's do one which is white. Let's do this one white. Okay, I'm going to check it. Let's do this one red. Oops. F. Let's do this one green. F here, and let's do this one blue. Oh, there. Then let's do this one FF. This one FF like that. This yellow. Then let's do this one F and F. Let's do this one 8. And then this one 8. Then this one 8. So now we have them all filled. Let's see what's going to happen to the image, because if it doesn't, if we take these colors, that means our routine has got a problem, and we will try to solve it. Let's see. But anyway, you can see that with this extension, no, still the same colors. So we are writing there, but we are writing not proper color values. So it didn't take our colors, but it stayed the same. Notice that, as I said, with this extension, I'm always in Visual Code and I'm assembling and running code on the Amiga directly without leaving Visual Code. This is, I hope, a super mega bonus for beginners, because I have to say, while I was doing the book, well, I'm still doing the book, but I don't know how many times I got questions from people asking me how to set up their Amiga, and I point them to my video of how to set up the Amiga. You do not need to set up an Amiga, you can just start coding now. And that is the beauty of the extension. I'm quite pleased with what Paul did, and I cannot stop thanking him. Oh, you are right. Oh, oh, yes. I have a mistake here. I should do, because I did an addition there, because you cannot do addition on address registers. Yes. You see? Move.long is 0, comma, A1. A0, sorry. Yeah. Jesus. That's really stupid of me. Let's put it this way, but you know, when you're coding, you do so many times this mistake. So I was thinking the right way here, that I needed an address register to move from one to the other, but I didn't realize that I haven't set an address register up here. I just left it on a data register. So let's run it again. So let's stop it, save it. Thank you, Hound Dog, for that. Sorry for Clumsy for that. Very nice of you. And now it should do the colors. Let's see. Yeah! Hurrah! There you go. We have our image displayed on the screen. Thank you very much, Clumsy. So first of all, give me a second. To be honest, your comment was below his, and I saw I read his comment, but because I'm looking at the from the side, I read yours. But yeah, so because of that, first of all, for those that stayed with me till now, I'm just going to, oops, I'm just going to move here so that you don't see it. I'm just going to give points to everyone. So thank you for staying in the stream. So where is my bot? There you go. So you all get 10k of points. Thank you very much. And to Clumsy, come on, I need to find Clumsy. So you're not coming at you are not following Clumsy, because it's not showing me you're not there. So I was going to give you points. But yeah, it's okay if you're not following. But thank you very much for indicating what I did. This is what I like. When people notice my mistakes, because like that I don't spend hours debugging. Really? It's not showing you. It should. It's not showing you for some reason. I need to check why it's not showing you. But anyway, I will give you the points. Don't worry, even if it's after the stream. No, it will. Maybe it hasn't updated. You know, that's why. But thanks if you're following. Thank you. So I promised you the extension. No. So let's close this. We finished what we needed to do. I told you I want to open a screen and display an image, and we have done that. Okay, as I said, please do not worry if there's a long copy list which I haven't explained. It assume the more we add code, the more I will need to explain of that. So let me find the link, and this is the extension link. If you don't have an account with Mega, you need to create an account with Mega, but I'm going to share the extension. Okay, you can go and download it. Please try and download it now and tell me if you have, I mean, one of you, if you can try and to download it, I would appreciate. And tell me if it's all fine. But you should all be able to download it if you have an account in Mega. Basically, let's see if I okay. Okay, perfect. So you managed to download it, HomeDoc. Perfect, thank you. So you have the extension. I will be sharing this code. You will get this code, but don't expect me to be sharing all the code of this. I will also be populating. Where is it? Did I close it? I'll show you. I will be populating this with all the tasks that we need to do, and each time so this one is completed and we can move it there now, and we can you know, do the game basically. But I think we have achieved quite a bit by having a screen on the Amiga. As you can see, it's not opening a screen, just there's quite a bit of things to do. I mean, many people do not understand this for the Amiga, I have to say. They still think like in the 8-bit era that you have a screen. In the Amiga, you need to create a screen. So I hope you have a good weekend. For those that follow me in the book, on the book, so on the streams of the book, so tomorrow the Italian and Saturday Sunday the English. See you tomorrow or Sunday. Guys, have a good week. Thanks Clumsy again for the bug that you solved for me. That was really quick. Thank you, Okenan. I'm sorry if I say the names wrongly, but hope to see you in the next stream and hope that you enjoyed it. Okay, thank you very much and bye-bye.